Hello everyone, I'm Ronald Seo of Ribose. A special thank you to the APMP DXFG Focus Group for inviting me today. I'm going to speak about a topic that I am personally very excited about. We believe this is a revolutionary approach to standards. For those who have a very ingrained idea about standards and compliance, please keep an open mind. You may love or not what you see. Let's first start with a general introduction to the topic, which is called SMART. SMART stands for loosely as standards that are machine accessible, readable, and transferable. Formally, SMART is defined as a class of standards that can be consumed by machines without necessitating human intervention. In other words, these are standards that are provided as structured data instead of as documents. So here's the million-dollar question. Why SMART? It is a fact that users of standards today increasingly rely on technology, and that they have been incorporating standardized content into information systems for utilization. Unfortunately, due to the format that standards come in today, users end up spending significant and technically unnecessary efforts to transform that content. The goal of SMART is to provide standardized content in an unambiguous way, in digital form, providing building blocks to enable digital transformation. I'd like to talk about the three aspects important to the achievement of SMART: goals, usage, and technology. Goals provide the why. Why do we need SMART? What are the assumptions and goals? You'd be surprised that many in the community may not necessarily agree on these basic questions. The how is how you use SMART. How can users benefit from SMART? What will they be able to do that they cannot do today? Last but not least is the realization of SMART with technology. How can you make it work? What are the technical elements needed to make SMART happen? SMART originally started in ISO in 2019 from the Special Advisory Group on Machine Readable Standards. This is where the SMART acronym was originally coined. SMART was incorporated into the ISO 2030 strategy as a strategic goal, and as a result, ISO established the ISO Smart SG in ISO Council. IEC, on the other hand, also revamped their SG12 for digital transformation to handle SMART. Regional and national efforts also started around 2021. Earlier this year, in 2022, IEC reached out to ISO to work together on the topic. That's why now we have the IEC/ISO Smart Collaboration Framework. So what is this IEC/ISO Smart Collaboration Framework? Let's have a look at what they've done. The IEC/ISO Smart Collaboration is a joint strategic program between IEC and ISO. The organization of this group differs from joint technical committees like JTC1, which only deal with standards. This program is managed at the highest governance levels between the IEC board and the ISO Council. This collaboration holds a mandate, therefore, not only dealing with technical matters, but also business models and governance processes. The linchpin to this collaboration is a joint coordination group called the JCG, with underneath it 3 joint groups. However, the smart technical groups of IEC and ISO are not joined. IEC SG12 and ISO Smart Technical Solutions operate independently of each other. Under the collaboration framework, there are 4 types of groups. The Joint Business Model Group is tasked to identify business models and provide recommendations on them, as well as any legal implications. The Joint Use Cases Group is to discover needs of users and find out how SMART applies to standard users. The Joint Conformity Assessment Group, which was just recently created, is in charge with providing recommendations on how to apply SMART in conformity assessments and testing. The ISO Technical Solutions Group, with IEC SG12, are to provide recommendations about technical solutions and on how they can integrate into the ISO and IEC production workflow. One of the key deliverables of the SMART work is to have a harmonized vocabulary, and these are the basic concepts of the SMART program. SMART content is embedded within SMART standards, facilitated by SMART technology, which allows delivery of SMART products and SMART services. Other than a harmonized dictionary, there are several concepts that are relevant to the application of SMART. These include the SMART levels, SMART governance models, and the SMART information models. I will briefly explain them. These are the ISO SMART levels, which I find useful in explaining how SMART content can be categorized by how digital they are. Basically, the higher level of a deliverable, there is higher fidelity of information. That means that the semantics are better preserved at higher levels in a digital way. At level 1, content is communicated in undifferentiated digital content, such as images, so not much semantics are provided. At higher levels, more semantics are provided and the opportunity for misinterpretation becomes much reduced. The SMART governance models determine the types of standards that can be made. Today, ISO and IEC are focused on producing content standards and database standards, as shown on the left. In the future, to facilitate SMART, we will also be standardizing automated processes that create those standards, as well as deliverables that are derived from the automated processes. To deliver SMART, which is digital content, it is important for us to know the information models to use for the encoding and delivery of standardized content. There are a large number of information models today, and different industries have their own favorite set of modeling languages. Our rule is that whatever works for the user is the right solution. SMART is not about enacting barriers, but breaking them down for the digital user. Now, I know you might have this exact question in mind. What exactly is SMART? What does SMART really mean? You've not shown me anything about SMART. SMART is still an evolving topic, but in this presentation, I will provide two concrete examples of how SMART works, and that is already possible today. I really like this picture, by the way. SMART means throwing out assumptions. This is a very famous quote, quote unquote, attributed to Henry Ford, but still, it is a fascinating quote. And here we're not looking for faster horses. SMART is not about the length of documents. It may not even be about documents at all. This is, according to BSI research, the life cycle of a standard. Some standards makers make it a big deal that a standard takes long to develop, but in reality, the time is mostly spent in implementation, and subsequently the users of the implementation, such as users of a quality management system, are required to live the standard. Most of the time is time taken to understand and interpret the standard and to figure out the correct way in implementing the standard. With SMART, we want to compress this. When adopting a standard, the less handover steps there are, it means less time wasted. By using SMART, we have an opportunity to compress a number of steps. Here, the interpret, adapt, apply, and measure steps can be compressed into one. Through digitalization, a SMART standard enables additional operation models, including test-driven standards development, standards as a service, and enables standards users to perform continuous assessments or continuous audits, and also link up the performance with benchmarks and potentially AI. To achieve that, we are going to state that a standard is not a document. Standards can be expressed in document form, but themselves do not need to be documents. Standards can be expressed with structured data and can contain things like data models, ontologies, model-based content, data and process requirements, terminology, etc. So how does all this become useful? Here's a real-life example using the authoritative document for SI units, the SI brochure published by the BIPM. The BIPM has established a digital SI framework that is driven by the CIPM task group and expert group on the digital SI. It defines two separate planes, the data plane and interoperability plane, that allows reuse and interchange of digital metrology data. The BIPM has embarked on transforming the SI brochure into a semantically enriched version that is machine readable. This deliverable is still in draft. This brochure is delivered in document form at SMART Level 4. It is achieved through using an open source standards toolchain called Metanorma with a units representation framework called UnitsML. This work is available open source, but the usual disclaimer applies. This is still a draft. The original SI brochure had some content at level 1. At level 1, we have undifferentiated content. This arrow points to a particular theta because that theta is a special character meant to be what is called the bold mathematical theta, which has a sans serif appearance. Unfortunately, that character does not exist in Unicode. In the original SI brochure, this character is encoded using a normal capital theta with a particular font, which has no mathematical meaning. Some math symbols were even encoded in images. This becomes hard to reuse, as if someone just copies and pastes it. It would just be pasted as a normal capital theta, which could look very different using different fonts, according to the whims of the font designer. This is also from the original SI brochure, where some content was at level 2. At level 2, we have presentational. These units here are encoded as text, which is still the common way to encode them in Word. So while they look right, they cannot be reused. Whoever uses them, or copies and pastes them, would need to re-implement the semantics. The semantic version of the SI brochure is at level 4, but let's suppose if it was at level 3, then it would look like this. At level 3, we have presentational MathML. It communicates the presentation structure of the unit, but it is unclear what the J and S really mean here. In any case, the rendering of it at level 2 is correct. At level 4, which is the level used by the semantic version of the SI brochure, UnitsML is applied to presentational MathML. This allows us to exactly know the unit used and the quantity. Here you can see it refers back to the unit's DB entry, which is part of UnitsML, and that the level 2 rendering is identical to that of before. At this level, this content is copyable from the XML with fully preserved semantics. If the semantic SI brochure was at level 5, it would have looked like this. Unfortunately, the content MathML of MathML 2 is not mature enough for interoperability. But this possibility would open up with the new MathML version 3 that is currently under development. At level 5, we would stay only with content MathML with UnitsML, so there are no more presentational hints. This is the cleanest structure and therefore is the most reusable, given the formula is a piece of digital data. Now, let's have a look at what happens when SMART goes beyond documents. Ribose SMART takes a revolutionary approach to SMART, where many assumptions about standards have been thrown out. Ribose, together with our partners, aim to provide open technologies and open source solutions for SMART. The Ribose SMART program started as a collaboration with BSI, with support from the UK Ministry of Defence, and also is now supported by the Standards Council of Canada. We thank Callum Sim, the head of Defence Standardization of the MOD, for providing us with this generous quote. Previously, in order to incorporate standardized content into information systems, it would have required immense effort to do custom development, to digest the text, understand the text, and implement functionality. With SMART, we can represent standardized content in SMART models, and have those SMART models directly translate into functionality. What we call SMART models are actually computer executable models, created in a specialized modeling language called Multimodal Modeling Language, also called MMEL, which is a domain-specific language developed to handle the intricacies of content within standards. It supports data and process modeling as well. This is similar to what happens with ebooks in an ebook store or an app in an app store. All you needed to do is to download the content and have it run on your computer. This is how SMART could work. There are three major components of the SMART suite. 1. SMART Tools. This is software that can author, edit, and run the SMART models. Next, we have SMART Modeling, the rules and languages used to represent standardized content in machine-readable form. Last but not least, the content. To have SMART work, we need to have the standards enriched into SMART models. For example, BSI has a catalog of digitalized SMART standards that can be interlinked with regulations or international standards. I'm going to show you the SMART version of PAS 2060. It is the international de facto standard for carbon neutrality. It specifies a set of measures and requirements to demonstrate carbon claims. For past 2060, normally the standard user would have to read the text, understand the formulas, then implement them in some way, and figure out where these formulas stand. In SMART, the standards makers would have already embedded that information in the SMART standard. And as a result, the standards user can directly type and click to verify that the numbers match. Here, we'll first open the model and navigate through the model to the location of the measurement tests. Then we input the necessary values. You can see that the test would return a pass or fail given the input, and it would highlight exactly where a failure lies and why it failed. So after the passing result, if we change this value into a failing one, you'd be able to see exactly where the value has failed. Now, going further with past 2060, we can actually utilize this model as a continuous compliance model for continuous auditing. First, we'll open the model for past 2060. Then we see a dashboard that we can stream data into the SMART model. Now we enter the sensor reading source, together with the proper locations of these sensors. Then you would be able to see data streaming in. Once the data streams in, you'd be able to see on the dashboard that the values are in green and they are currently passing. To conclude after the demonstrations, I hope you have found the presentation useful. In summary, I'd like to repeat that SMART is a new class of standards. It's not a single new technology. SMART is an evolving topic and therefore will grow and change. SMART will enable new use cases for metrology, such as for testing and compliance. SMART technologies exist today and are improving. Many SDOs, including ISO, IEC, and BIPM, as well as national standards bodies, are all experimenting with this topic. Lastly, if you or your organization is interested in working with ISO and IEC on SMART, please feel free to contact me or any of our representatives. Thank you very much.